descent and landing of InSight on Mars. Marco A separates 1 hour, 29 minutes into flight, followed 48 seconds later by the separation of Marco B.
From the Mission Director Center, we're about T-minus 4 minutes and holding. We have about 14 minutes, 40 seconds left before a liftoff. With that, we'll go back to Stephanie Martin. Stephanie?
Hi, I'm Stephanie Martin. For those of you just joining us on social media, we'd like to welcome you to launch coverage of InSight, which will give Mars its first thorough checkup since it formed 4.5 billion years ago. InSight will take the vital signs of Mars, including its pulse, its temperature, and its reflexes. InSight is flying on United Launch Alliance's Atlas V 401 configuration and has a 2-hour launch window starting at 4:05 this morning Pacific Time or 7:05 Eastern Time. This means that the launch team has 2 hours to lift off from Space Launch Complex 3 at Vandenberg Air Force Base. InSight is set to land on November 26th in the Elysium Planitia region of Mars, which is about 373 miles from the Gale crater, where NASA's Curiosity rover landed in August 2012. After InSight lands, it will spend 728 Earth days, or a little over a Martian year, studying the planet's interior. After the spacecraft's roughly 6-month journey to Mars, it will begin its landing phase. InSight will be the red planet's first thorough checkup since it formed 4.5 billion years ago. InSight will take the vital signs of Mars, its pulse, its temperature, and its reflexes. After InSight enters the Martian atmosphere, traveling 13,200 miles per hour, it deploys its parachute and ultimately slows down to 5 miles per hour for touchdown. 1 minute later, InSight will begin surface operations, checking out the lander's health indicators, then deploying its 2 solar arrays. It will take about 10 weeks to place all the instruments onto the ground, and about 7 weeks later, the self-hammering heat probe will reach 10 to 16 feet into the Martian soil. There are about 2 briefcase-sized CubeSats known as Mars Cube 1 or Marco hitching a ride on today's mission. Now with that, let's go back to NASA's Joshua Finch in the Mission Directors Center.
A27. Yeah.
I take that back. NASA's new administrator, Jim Bridenstine, shares his thoughts on NASA's InSight mission, the future missions for human exploration plans, and what NASA's impact is on the world.
So what Mars InSight lander is going to allow us to do is really map the inside of Mars. This is an important mission, not just for the United States, but an important mission for the world, so we can better understand why planets change and ultimately understand even more about our own planet. I think the one thing that really excites everybody is a question that we ask ourselves over and over again, which is, are we alone in the universe? Is there potential for life on a planet that's not our own? And one of the things that we want to do with Mars 2020, which is going to launch during the next window we have to go to Mars, is understand if there was a potential, or maybe even Mars might have at one time hosted life. If we want to get as much science as we can, as fast as we can, we need to get really good at using robots. We're going to have robotic missions to the moon before we have humans go to the moon, so that we can get the most out of our human science missions. And that's true on Mars as well. This president and vice president are very committed to getting America back to the surface of the moon as fast as possible. Earth, because we live here. And it's the only planet we know that can host life, so we better take care of it. When I was 5 years old, they made us draw what we wanted to be when we grew up, and I drew a picture of an airplane. I had a picture of myself there wearing a hat that I thought airline pilots wore. As a pilot in the Navy, I became very dependent on space-related capability. And a lot of the technologies that come from NASA have multiple uses and have transformed the way we live our lives. So people say, why are you interested in space? I think the question is, why wouldn't you be interested in space? It's critical to our everyday lives. So this is a critical mission for our country. It's a critical mission for the world. These are some of the brightest minds that our country has. We've got great international partners, and our nation is grateful, and in fact the world is grateful for their service.
It is great to hear from our new NASA administrator. Now remember, you can follow him on Twitter using @JimBridenstine. We're now a little more than 9 minutes away from today's launch. Let's go to NASA's Joshua Finch in the Mission Director Center for the final countdown of today's launch. Josh?
Thank you very much, Stephanie. And I'm actually being joined by Alyssa Macbeth from United Launch Alliance. Alyssa's going to give us a little more insight in today's mission. Alyssa, can you tell me about your role at ULA and what it's like to work for InSight?
Yeah, thanks for having me here. So I work at the launch site. I'm a systems engineer for launch operations, mainly in the avionics department. So that covers everything from batteries to harnessing to the flight boxes that takes the rocket to where it needs to go in outer space. My personal role, I'm also involved with ordnance, so installing all the pyrotechnics that separate the stages, separate the spacecraft from the vehicle on orbit, those kinds of things. So that's mainly what I'm involved with. And on InSight, I was able to, it's my first West Coast launch, and on InSight, I was able to come out here for the past couple of weeks and do just that, install batteries, install some ordnance, and do some final connections.
So you're often on console for your ULA launches. Can you tell us what it's like to be on console?
Absolutely, yeah. So on console it's an experience. It's very exciting. The adrenaline in the room, you can feel the energy. There's a lot of system testing happening just to prepare the rocket for launch and verify that everything is in configuration and nominal. We fuel the rocket at that point, T-minus 2 hours and counting. And then it's really just some final checks to verify that everything is good. We've got a team of people at the launch site sitting on console, as well as our certified responsible engineers in Denver, who are also having a second set of eyes on the systems as well.
And so can you tell me what's happened up to this point in the countdown and what we can expect before launch?
Yeah, so we're getting up to the terminal count now. So terminal count is T-minus 4 minutes and counting. So up to this point, the rocket is fully fueled. We're doing some final system checks. All of the testing that I talked about earlier is completed, and we are doing our final, we're ready to go. So we'll get into a status here soon. All the systems will go through and say, yep, we're good to go, and we'll be ready.
And we're about 10 seconds away from that pull now, so let's listen in.
Okay.
LCAC
L-minus 7 minutes.
Go AC. Confirmation from OS that we are in the correct RF patch configuration.
Roger. Status check to proceed with terminal count, Atlas Systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur Systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HASGAS.
Go.
Electrical Systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GC cubed.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Ops safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
LC, you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1105 Zulu.
Verified.
OS, start list data capture.
And as you've heard, that poll is now complete. We are still within the hold, the T-minus 4 mark. But with the L clock, we're about 5 minutes, 40 seconds away from launch. And Alyssa, one last question for you. You have teams working at this launch site, and then you have teams in your company headquarters in Colorado. Mm-hmm. Can you tell me about how they're working together?
Yeah, definitely. So in Denver, like I said, those are our certified responsible engineers. So these are the experts in the system. They know everything down to the minute detail. So they're looking at the data as an overall system, but also digging into the details. At the launch site, we're in the countdown. So we're running the tests, we're sending commands, we're pressing buttons and doing those kinds of things, and working together with them as a full team, ULA team, to get it ready.
Sounds great, and thank you very much for being with us today for the launch, and we'll continue the countdown. Thank you very.
Thanks so much.
And with that, we'll continue keeping track of all the things that are happening as we lead toward liftoff. So let's get you up to speed. And first, welcome to those who are just joining us on social media. As you can see, we have a little bit of fog in the area today. You can see the Atlas V and its 401 configuration, and it's stacked on the launch site at Space Launch Complex 3, the West Coast launch site for the Atlas V. The Atlas V has many different configurations, but this 401 configuration means that we have a 4-meter payload fairing at the top. The 0 indicates there are no solid rocket motors for this mission, and the 1 indicates we have a single-engine Centaur upper stage. We are about 10 seconds away from coming out of the hold in our count. 4, 3, 2, 1. And we are at T minus 4 minutes and counting. The United States Air Force has been monitoring weather for us, and as you can see, some fog on your screen, some visibility issues, but that's not a constraint for launch today, so we are green on the range in terms of weather. The Air Force range is also responsible for public safety during launches from here on the West Coast and has been coordinating with United Launch Alliance and the NASA teams, ensuring that launch area and the flight path are clear for the launch of the Atlas V rocket, and we have no collision avoidance cutouts or COLAs during the window today, but right now we're tracking to a 4:05 Pacific time launch. We're at T minus 3 minutes, 20 seconds and counting. The Atlas boosters and Centaur liquid oxygen tanks are at flight levels. The NASA launch manager, Tim Dunn, has polled his launch team. The United Launch Alliance launch conductor, Lou Mangieri, briefed launch teams ahead of the terminal count. The launch conductor has also verified with the range controller that solar radiation is acceptable for launch.
Securing LO2 topping.
2 minutes, 50 seconds.
Atlas tanks the flight pressure.
FDS internal.
We're at 2 minutes, 45 seconds to launch. The flight termination system on the Atlas V has just gone to internal. We're at just about T minus 2 minutes and counting.
1 minute, 59 seconds.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
FDS armed.
You're looking at a live shot of the encapsulated spacecraft on top of the rocket at Space Launch Complex 3.
OCU armed.
FCS
The
count
launch
started.
azimuth or flight path tonight will be in a southeastern direction, hugging the coast of Southern California and Mexico.
1 minute, 10.
Vent valves locked.
We're about 1 minute, 5 seconds away from launch.
T minus 1 minute.
Rock, report range status.
Rock, range is green.
And we've just heard confirmation that the range is green. After launch, we'll be hearing the voice of United Launch Alliance's Marty Malinowski. He'll provide a status of the flight of the Atlas V and NASA's InSight.
Minus 40 seconds.
We are listening in to
Stable
the
at
final
step
minutes
3.
of the countdown.
Minus 28 seconds. 25.
Go Status
Atlas.
check.
Go Atlas.
Go Centaur. Go Insight.
We're at T-minus 15 seconds. 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the Atlas V, launching the first interplanetary mission from the West Coast. And NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
Controls. Good. Check the pressures and RPMs. Inspect the dam at this point. RD-180 continues to look good at this point in the mission. Check the pressures, pump speeds, expected regions, extra ratio, controlling within expected parameters.
The RD-180 engine providing 860,000 pounds of thrust.
Vehicle body rates continue to look good. All booster systems look nominal at this point. Mach 1.
The rocket is now traveling faster than the speed of sound. Coming up, the rocket will enter max Q. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Coming up on the throttle down. Booster has throttled back, right on schedule. Signatures look good. Pump speeds, injector pressures continue to look right within band. Body rates controlling down the middle. Current altitude is 13 miles, downrange distance 7 miles, current velocity 1,965 miles per hour. Closed loop guidance has begun.
The first part of the flight was pre-programmed trajectory. Now the rocket is giving itself feedback on its flight path.
And Q alpha steering has begun. Body rates look good. Pump speeds, injector pressures, all within band. RCS pyro valve has been fired. System is now pressurizing flight level. Signatures look good. Current altitude is 30 miles, downrange distance 43 miles, current velocity 4,542 miles per hour.
You are looking at a live view from the Atlas V rocket. The RD-180 engine continues to burn.
Body rates continue to look good. RD-180 is still performing well. Q alpha steering has been completed. Booster is now 1/4 of its liftoff weight. Currently flying at 4 G's acceleration. Boost phase cooldown has begun. Pogo pyro valve has been fired. Moving the throttle to 5 G's.
We're 3 minutes 50 seconds into flight, and we're nearing booster engine cutoff, or BECO.
Back to 4.6 G's in preparation for BECO. Boost phase cooldown has completed. And we have BECO. Shutdown looks good.
And the RD-180 engine on the first stage of the Atlas V has shut down.
Stage separation. We have box and fuel pre-start. The GN2 purge firing of the RCS is underway. We have ignition and full thrust on the RL-10.
And the second stage engine, the RL-10, has ignited.
And we have indication of payload fairing jettison. Looks like a good step.
And the payload fairing that was encapsulating the InSight spacecraft has been jettisoned. The RL-10C engine, the second stage of the Centaur, continues to burn. You're looking at live animation telemetry
Look very good.
of the Centaur second stage on its flight path.
Our GN2 purge firings underway for thermal conditioning. Pump
As you can
speed,
see to the bottom right of your screen, the flight path of the rocket.
discharge, all been banned for the ZMR. And Centaur has gone to closed loop PU control in a slightly fuel-rich mixture ratio correction. And a quick look at the booster stage performance shows a very nominal booster.
For those of you that are just joining us, we had an on-time liftoff of the Atlas V rocket carrying NASA's InSight spacecraft, as well as two small CubeSats called Marco.
This burn is scheduled for 8 minutes and 56 seconds in length.
You are looking at a live shot of the Centaur second stage, the RL-10C engine providing thrust.
And the RCS line temperatures are warming to throttle temperatures as expected. Centaur now controlling just slightly fuel rich. Chamber pressures, LOX pump discharge, and fuel venturi all within band.
We're at 7 minutes, 15 seconds into the flight. InSight being taken to its trajectory. This will be the first of two burns of the second stage.
All Centaur systems look very good at this portion of the burn. Up on the roll to optimize to Tidris East.
And Tidris East is a tracking data relay satellite east.
And the RL-10 again continues to perform very well. Again, requesting a fuel-rich condition at this point in the burn. Chamber pressures, LOX pump discharge, and fuel venturi, all parameter. RCS line temperatures have nearly achieved bottle temperatures. Continue to see our thermal conditioning firings on the RCS. Tank pressures are stable. Body rates look good. Storage bottle levels are excellent.
We are just over 9 minutes into the flight of InSight.
And Centaur PU is now controlling at a nominal MR. Engine response looks good.
You continue to see the flight path on the bottom right of your screen.
Centaur is currently flying at an altitude of 136 miles. Downrange distance is 1,261 miles. Current velocity 14,066 miles per hour.
This trajectory of the flight path will put the spacecraft and the Centaur in a park orbit before crossing the equator. It will go around the southern tip of South America. It will cross the southern edge of the Atlantic Ocean, come up over the Indian Ocean to the east of Africa, and cross over India.
Continues to control near nominal. RL-10 performance is as expected for the SETMR. Centaur is currently at an altitude of 131 miles. Downrange distance 1,461 miles. Current velocity 14,790 miles per hour.
We are 11 minutes into the flight of InSight. We have about 2 more minutes left in the first burn of the second stage RL-10 engine.
2 minutes to MECO. Centaur continues to look excellent at this point. Tank pressures, body rates, throttle pressures, all in family.
We're coming up on about 1 minute left in the burn of the RL-10 of the second stage.
1 minute remains in this first burn. Centaur PU controlling near nominal. RL-10 chamber pressure, LOX pump discharge, and fuel venturi, all appropriate for the SETMR. RCS line temperatures look good. Still seeing thermal conditioning firings.
And we are now 13 minutes into flight, very close to the second stage engine cutting off for the first time for one of 2 burns that it will take.
Centaur is now orbital. And we have MECO. Engine shutdown looks good. We have 4S settling motors on.
And you just heard confirmation from United Launch Alliance, Marty Malinowski, that we've had MECO. The second stage engine has cut off for the first time. The first burn of the second stage, RL-10, being complete, we now begin the long coast phase of this mission. The coast phase will end when the RL-10 engine ignites for the second time for over 5 minutes. Start of the second Centaur burn will begin over northeast Russia. The end of the second Centaur burn will be completed over the northern Pacific Ocean. After the end of the second burn, we'll coast for about 9 minutes so that the Goldstone Deep Space Network is in view for the separation events of the InSight spacecraft and the 2 Marco spacecraft that are traveling along. And that will happen over northeastern Pacific Ocean off the coast of Oregon. So with the long coast phase underway, we'll now go back to Stephanie Martin. Stephanie?
Thanks, Josh. For missions to other planets, the flight path has to be extremely precise to ensure the spacecraft lands or orbits in the correct direction. NASA's Amanda Griffin sat down with Callie Burke, the trajectory analyst for the InSight mission, to learn more about her work for today's mission.
So Callie, tell us a little bit about your role for InSight.
My role is the trajectory analyst here at the Launch Services Program. And so my job is to make sure that the rocket drops the spacecraft off at the right place and time and space. We have to consider these really complex journeys. You know, it's not just doing an equation once. The Jet Propulsion Lab, they do these things called pork chop plots. And so they consider many months they could launch and many months they could land on Mars. What's the weather conditions going to be like when they get there? We want to get communication during landing. So are the right satellites in place, or are we looking back at Earth at that time in the landing site? So there's all these considerations. And so we have 35 days we're looking at that we're launching, but only one day that we're going to land. We actually have a 2-hour window that we're able to do on each day. And so that's 25 opportunities. So there's 875 possible ones we analyzed.
Wow.
Yeah.
So to launch from California, what's different?
Here from Florida, we launch east safely, and we can go somewhat to the north and somewhat from the south. But from Vandenberg, if they launch east, they're flying over people, and so we don't want that. So we can launch to the southeast, as we are for InSight, and then we can continue going west and launch safely.
So we've heard a lot about planetary protection.
Mm-hmm.
So what is that, and what is your team doing to try to help mitigate that in Mars?
So we have somebody here at NASA who's called the Planetary Protection Officer, which after a 9-year-old applied, I now jokingly, it's the guardian of the galaxy. That's why he said he'd be great. But the Planetary Protection Officer looks to both protect Earth from any microbes we bring from space, and then we also consider Mars and Europa, where we think there might be life. We want to protect them from bringing Earth bugs and basically creating life somewhere as opposed to finding it. The spacecraft, which we plan to have land on Mars, has been very specially clean. There's a whole team, but we don't do that with the rocket. We actually aim the trajectory a little bit away from Mars. We don't aim it straight at Mars, so that we don't pollute Mars.
Well, here's wishing you all nominal calls on launch day.
Thank you.
And a successful flight. Thanks, Callie.
We are 17 minutes into the flight of NASA's InSight spacecraft on its way to Mars. Our own Tori McClendon is in the Remote Launch Control Center with Scott Messer, the United Launch Alliance Program Manager for NASA missions, to get an update on today's launch. Tori?
Thank you. So, Scott, tell us how it's going so far.
Well, so far, Tori, things are really good. It's a very nominal count, and it's a beautiful, beautiful launch. A little foggy out there, but everything is going well and right on track.
All right. So, as we all know, United Launch Alliance is definitely no stranger to Mars missions. You've launched the Spirit and Opportunity and the Curiosity rovers. So what is it like to now have sent InSight on its way to Mars?
Yeah, so you're right. We're very excited. We've actually launched every Mars mission since 1960, so we've done a lot of them. And but this one is super exciting, obviously, because we first launched from the west coast of a planetary mission onto Mars. So it's very exciting. And anytime we go to Mars, it's very exciting for us to give our customer a great ride and create mission success so that the InSight mission can do what it needs to do when it gets to Mars.
So this has been a very busy year for you guys so far. Let's see, this is the 5th launch for United Launch Alliance.
Yes,
so far in 2018. It's the 2nd NASA mission. All right, so what's up next for the team?
So we've still got 2 more missions left to go. We've got the Parker Solar Probe mission going to the Sun, which launches in July, and then, of course, our last Delta II mission, which launches in September from out here in Vandenberg. So a busy year for us with 4 missions, and very excited.
Oh, thank you very much. We're looking forward to the rest of the year and the rest of today. Thanks, Stephanie. Back to you.
Thanks, Tori. With many scientific missions, NASA partners with international space agencies to explore and discover new science. In fact, InSight has instruments from France's National Space Agency, called CNES, and the German Aerospace Center, known as DLR. NASA's Blair Allen has more.
Thanks so much, Stephanie. Yes, it's very exciting. We just witnessed an incredible launch, and we're here with two very important members of the space community, Jean-Yves and Pascal. Thanks for being on the show.
Thank you.
Thank you. So I'll start with you, Jean-Yves. Just thinking about the significance of InSight and the partnership, tell us a little bit about what it means for the French Space Agency to launch and see a launch of the InSight mission.
In fact, as you know, we have a very strong scientific community in France which is totally devoted to Mars, and this is why we are on a number of Mars missions. And for us, InSight is perhaps not the ultimate, but a very, very important mission, because we are going to beat the heart of Mars with the seismometer that we put on board of InSight.
Yeah, and obviously that instrument is very important to the data that we'll get back. So we're very appreciative that you're participating as well.
Yes, and as you know, NASA is very selective in the choices which are made, and we are very proud to have been selected and to have a very strong partnership with NASA and JPL during the last 10 years. And I am sure that we will have a tremendous success once we will receive the data.
Absolutely, absolutely. And Pascal, how about for you and the German Space Agency? Tell us a little bit about what it means to see the significant mission start today.
Well, Germany is active in Mars exploration since more than 2 decades. Just you remember Mars Express and our high-resolution stereo camera scanning still the surface of Mars, and also contributing to many other U.S. missions to Mars. And we are very, very excited today that you know, our instrument, the heat flow and surface properties packages, HP3, much easier to remember, will, you know, is on board, is on the way to Mars, and will really reveal new insights about the interior of Mars.
Yeah, and this is really exciting here tonight because we have a scientist by profession and an engineer. Tell me, Pascal, a little bit about what it means for you as an astrophysicist, from that perspective, what it means for you to see InSight launch.
Well, I think we want to understand our neighbor planet, Mars. It had a very similar history in 4.5 billion years ago. We want to understand how the planet evolved and developed. It's important to understand how terrestrial planets evolve, and we learn from the experiments on InSight about that. And I think one of the important things is also that is really linked to, you know, how life actually originated on Earth and eventually on Mars, and that is a very important aspect.
Absolutely. Thanks so much. And Jean-Yves, an engineering perspective, how does it feel for you as a former engineer to
Oh no, but launching to Mars is probably the ultimate launches. It's my third launch to Mars. I was in Baikonur in June 2003 for Mars Express. I was also in Baikonur in March 2016 for the first ExoMars and tonight. But the other launches finally are very simple. You have to launch. Here you have to launch, to cruise, to land, and to discover. And this is probably the ultimate mission for an engineer.
Well said, and thank you both for being on the show. We really appreciate it, and we're as excited as you guys are to see Mars InSight land and start getting inside the Martian surface. So back to you, Stephanie. It's very exciting. I hope that you can sense the excitement of myself and the international community here.
Thank you, Blair. We're so excited here in the studio as well. Now we want to test your knowledge for those of you tuned in online. We've got some InSight trivia. Do you know the answers? Understanding the complex geological formation of Mars is an essential part of helping us discover how our own planet's future could unfold. Sue Smrecker, the Deputy Principal Investigator for InSight, is on set with Blair Allen from NASA Edge to talk about what's happening beneath the Martian surface. Blair?
Thanks so much, Stephanie. Sue, I got to tell you, before we get started about the interior of Mars, tell me, what was your experience during the launch?
It was fantastic. It was physical. I could feel the ground vibrating. The car alarms were going off. And I saw a little spark in the sky. But that's about it. But it was, it was just as emotional as if there was no fog in the way. So it's on its way, and it was thrilling.
Well, I'm so glad. I felt the same way. I didn't see it, obviously, but did feel it. And I tell you, it really is exciting, and now we're underway. And so let's talk a little bit about what's going to happen once InSight gets there, because the big objective is to get under the surface. So tell us a little bit about the science of getting underneath the surface of Mars.
Okay, so our main instrument is a seismometer, and so we use that to image the interior of the planet. Basically, anytime a quake goes off, it'll travel through the interior of Mars, it'll bounce off different density layers, and so it's like a sonogram. It'll bounce off when it change in the density of the planet. So we're going to measure the thickness of the crust. We're going to determine the seismic velocity of the mantle, which tells us about its temperature, and we're going to determine the size of the core. So all that structure.
Now, I'm wondering, the particular location that InSight, where it lands, was that chosen based on geological activity, or tell me a little bit about the region you're landing in?
So we're going to Elysium Planitia, and we are a competed mission, so we are trying to do things on a budget, and with the lander, it's a copy, if you will, of the Phoenix lander. So it had already kind of had some engineering constraints. So that meant we could only land at a certain altitude on Mars. We go in, we don't want to crash, we don't want to, and we also are solar powered, so we need to be near the equator.
Right.
So that actually narrows it down a lot. And then the last thing that we wanted is someplace where we can burrow our mole for the heat flow under the ground. And happily, Mars provides a window into its subsurface via impact craters. So our landing site lead, Matt Gollenbeck, and many students mapped hundreds of impact craters and determined the depth at which there's a competent rock layer. So we found a place where we can get our mole down without worrying about that rock layer at depth.
Well, I guess that's going to be pretty important for the mission, because it's going down pretty deep, I understand.
Yeah, up to 16 feet. So we think the first 30 feet or so should be okay in our region.
Oh, that's incredible. Now tell me a little bit about this mole. What kind of data are you actually getting with that sensitive instrument?
Yeah, so it hammers itself down and stops every about 1.5 feet. And it sends out a heat pulse, which tells us about the thermal conductivity of the soil. And then it keeps on hammering in steps down to about 16 feet. At that depth, we're away from temperature changes due to day-night changes, seasonal changes, and we're just getting the heat coming out of the planet. So we actually measure the thermal gradient with a string of temperature sensors that the mole pulls behind it. So with that thermal gradient and thermal conductivity, we get the heat coming out of the interior of the planet. So,
well, I tell you, it sounds like you've got the bases covered. Well, listen, thanks so much for being on the show, and good luck to you and the rest of the InSight team. Stephanie, we're learning a ton about what's going on with InSight. Thank you so much.
1 minutes into today's flight of NASA's InSight spacecraft on its way to Mars. Let's check back in with Joshua Finch in the Mission Director Center for an update on the flight.
Thank you, Stephanie. We had an on-time liftoff today at 4:05 Pacific. The Atlas V rocket roared to life with the InSight spacecraft. The InSight spacecraft is now, as you see on your screen through this animation, is traveling with the second stage. The second stage is on a coast phase. The RL-10 engine ignited for the first time and did its burn and is now shut off, and we're in a coast phase. As you can see from the bottom right of your screen, we're traveling just over the southern tip of South America, and this burn will be first burn was the first of two that we'll do. The second burn will put the spacecraft in the proper trajectory, and it will coast for about 9 minutes after this completion of that second stage burn, and then it will release the InSight spacecraft, and then a few moments later release the two Marco spacecraft at the bottom. But a beautiful liftoff in the pre-dawn sky at Vandenberg Air Force Base on the central coast of California. There was fog in the area, yet no constraint to launch. And speaking of launch, let's bring you some launch replays right now. And on your screen, you can see some animation of the second stage Centaur with the InSight spacecraft atop. And at the bottom of the Centaur, the two Marco spacecraft. We're in the long coast phase of our mission. And for right now, we've got some more Mars trivia for you, and we'll bring that to you right now. And you can see the InSight spacecraft atop the second stage Centaur of the Atlas V rocket, continuing on its flight path. We did have an on-time liftoff at 4:05 a.m. Pacific time. A nice launch in the pre-dawn sky at Vandenberg Air Force Base. We're still in our long coast phase for this mission before the second burn of the second stage engine. And while we're waiting, we'll now go back to Stephanie Martin for more. Stephanie?
Thanks, Josh. The twin Marco CubeSats will be the first small satellites to leave Earth's orbit. If the technology demonstration is successful, they hold a lot of promise for the scientific community. NASA's Chris Gerst is with Joel, the Marco lead mechanical engineer at NASA's Jet Propulsion Laboratory. Chris?
Hey, thanks, Stephanie. So, Joel, tell me about the launch.
Oh, it was fantastic. Even through the fog, you could feel the rocket lifting off of the pad and successfully clearing the tower and getting on its voyage. Really exciting time.
Now, take us to the next phases for Marco A and B.
Sure. So after about 90 minutes, the InSight spacecraft will deploy. 60 seconds after that, the first Marco spacecraft will also deploy off the second stage. The stage will roll 180 degrees, and then the second Marco will deploy.
Okay. So that's interesting because you're gonna let the InSight spacecraft go first.
Absolutely.
And then you guys are gonna be trailing.
Correct. Yeah, we all deploy off in slightly different directions, and then we fly as a loose cluster together over our 6-month trip to Mars.
Now, how do you think Marco A and B how are they gonna feel following InSight all the way to Mars?
Sure. Well, that's exactly our point. We are there to trail InSight, and we're eagerly awaiting our chance to fly over and catch up with them as they go through entry, descent, and landing. And we fly over and are able to relay their message back to the eagerly awaiting ears here on Earth.
Now, this is pretty cool because this is the first time we're taking a CubeSat that's traveling out of low Earth orbit and going to another planet. Kind of take us through that process. I mean, what are some of the challenges of actually designing a CubeSat, constructing it and getting it ready for flight?
Absolutely. Space is hard. That's one of the difficulties with any type of satellite. And with the Marco CubeSats, there's nothing any different. Traditionally, CubeSats in low Earth orbit, you're close to home. You have a lot of opportunities to talk to your spacecraft. You're in an environment that repeats itself since you're orbiting the same body over and over.
Right.
As you get into deep space, you're in a much different environment. You're perpetually moving further and further away from the sun.
Right.
You get less and less power every day. Your environment is changing. Additionally, you are very far from everything that is familiar. There's no GPS. There's no Waze that can help you navigate.
That's a good point.
And the deep space network is your only way to phone home.
Okay.
One of the technologies that Marco is demonstrating on this mission is a brand new radio, very similar to what is flown on these larger spacecrafts, but a quarter of the size. This softball-sized radio allows us to communicate with the DSN radio in order to do things like navigate on our way to Mars and in order to communicate with the Deep Space Network and understand how our satellites are doing.
Now, once Marco, and we're all assuming it's going to do its job beautifully once it gets to Mars, and it's going to help out the InSight spacecraft. Once that is done, where did the Marco CubeSats go?
Sure. So Marco's primary mission is a technology demonstration to learn about these technologies. If we survive our 6-month voyage and learn all of about these technologies throughout that trip, we'll do entry, descent, and landing relay of InSight's information. After that, the 2 Marco's missions is complete. We'll finish relaying down data and engineering data to sort of see exactly how we performed when we're relaying InSight's data for entry, descent, and landing. And after that, we'll sail off into the sunset and sort of be in a heliocentric orbit for forever.
That's incredible. In fact, it's sort of you're laying the foundation for future CubeSats to be launched to other planets.
Absolutely. Yeah. It's a real honor and an exciting time to be involved in this investment into the future of small satellites and satellites in general. It's a really surreal experience to have worked on this over the past several years and to be here to see the launch and experience everything that all of these teams have put into their satellites together.
Now, a little bit of piece of trivia for the audience. I believe, correct me if I'm wrong, that Marco A and B have special names.
Absolutely. So Marco A and B were given the names by the team of Wall-E and Eva after the Disney characters from the movie Wall-E. And that actually has some basis in what Marco actually is. So the Marcos are demonstrating a cold gas propulsion system, which allows us to allows us to correct our trajectory on our trip to Mars. In the movie Wall-E, there's a scene where Wall-E jumps out of the space station and is flying around with a fire extinguisher. Our prop systems are filled with the same propellant that is in common fire extinguishers. So we, in essence, are Wall-E flying through space powered by our fire extinguishers.
How cool is that?
It's very cool.
Well, Joel, thank you so much for joining us today. I can't wait to see Marco in action and perform admirably and helping out the InSight spacecraft.
Thank you, Chris.
Steffi, I don't know about you, but we got to come up with a special name for us because that's pretty cool having 2 CubeSats with special names. Back to you.
Thank you so much, Chris. Now, if you love that they are named after Wall-E, we've got some more InSight and Marco trivia for you coming up now.